Hi everybody, I'm going to work another example with derivatives and velocity, position, acceleration function. You can find the text of this on Blackboard, but I'll read it to you as well. Uh, if we have a particle whose position is given by x equals 4 minus 12t plus 3t squared, the first part of the problem says what is its velocity at t equals 1 second. And by the way, here t is in seconds and x in meters. Okay, so part A, what is its velocity at t equals 1 second? Well, we have the position function, but we know we can find the velocity from the position function by taking the derivative with respect to t of that position function, or derivative with respect to t of 4 minus 12t plus 3t squared. The derivative of, let's do it term by term, the derivative of 4 is 0, the derivative of negative 12t is negative 12, and the derivative of 3t squared is 3 times 2, which is 6t to the first power. So now we have a function that will tell us velocity. 6t minus 12. Let me write that a little more clearly. 6t minus 12. So if we are to say evaluate this at t equals 1 second, we will just plug that in for t. So velocity equals 6 times 1 second minus 12. And the answer is, I'm just going to leave the units out for now, negative 6. And of course this will be in meters per second. So velocity equals negative 6 at t equals 1. Part B says, is it moving in the positive or negative direction of x? Well, the velocity is negative, so it's moving in the negative direction of x. That's what that's all we have to look at. That doesn't mean it's in the positive region of x. It just means it's moving in the direction of negative x. So that's negative. Part C says, what is the speed just then? Well, the speed equals the magnitude of the vector velocity, or just v, so that's going to equal 6. And yes, I should put vector bars here. X is a vector too. So this makes sense because the particle is moving in the negative direction, but is moving at 6 meters per second in the negative direction. So speed equals 6, velocity equals negative 6. D, is the speed increasing or decreasing? Well, let's look at this. Okay, so we're looking back at the function here. At 1 second, the speed is negative 6. At 2 seconds, it would be 12 minus 12 is 0. At 3 seconds, it would be 18 minus 12, so that would be what? Positive 6 meters per second. So here's the problem though. The velocity is increasing. It's going from a negative number to a positive number, but it's on the other. If it starts out in the negative, the speed, 6 meters per second, has to decrease to 0 before it can increase on the other side. If we think of it like, okay, so this is a linear equation of, this is v, velocity, with time. So negative 12 is the y-intercept. That's somewhere down here. And and it has a positive slope, 6t. So the velocity is going to look something like this. We are down here at, let's say t equals, let's say this is 1. So right here, this is negative 6 meters per second equals the velocity. We haven't talked about vector bars yet. I'll talk about it shortly. So this number is going to continuously increase, but the magnitude decreases from negative 6 to 0 before it keeps increasing. So let's say this is 2. This is plus 6 meters per second. So the velocity is always increasing. It's going from a negative speed or negative velocity to a positive velocity, but the speed, the magnitude of the velocity, decreases to 0 before it increases again. Think about somebody running in the negative direction who then slows down and stops before turning around and going in the positive direction. So what was the question? Is the speed increasing or decreasing? Velocity is increasing. Speed is decreasing. Part E says, is there ever an instant when the velocity equals 0? If so, give the time t. If not, answer no. Well, we already said the velocity equals 0 at t equals 2 seconds. I can say that by looking at the equation for velocity that we derived and just saying that equal to 2. So then 6t equals 12. T equals 12 over 6 equals 2. Part F says, is there a time after t equals 3 seconds when the particle is moving in the negative direction of x? If so, give the time t. If not, answer no. Well, we kind of did this already because we drew the graph here, and so this is t equals 1, t equals 2, t equals 3. After t equals 2, it's a linear line, so it never goes back into the negative region again because it just keeps on going forever. So no.